Okay. So we'll start because it's 9:05. Um, so in fact, it's the first lesson from the second partial already. Um, Today we will see the origins of life and do some activities around it. And then tomorrow we will do a little closure of the first partial, which you will see tomorrow. So that's a little bit what we're going to do this week. Just want to remind you not to forget the core activity, okay, because this is due for tomorrow, and then I have to upload the grades. So Arturo and the other girl, Andrea, I think is her name, right? You still didn't present the exam because of these issues. I've been asking around, nobody seems to know. So now I have a meeting about this with some people in Monterrey that will have a look into this, okay? Because I also don't know what the problem exactly is. I believe it's some kind of bug in Canvas, I think. But I've been asking everybody in our prepa, my colleagues and even the computer people, and they don't know. They have transferred me to Monterrey, so hopefully they can give us some closure. So hold on, Arturo and Andrea. Don't think I forgot about you. We're gonna fix this, but I still don't have the correct answer of what the problem is and what we will. The only thing I can tell you is that it's not your fault, and in no way I will allow that it affects you or your grade. That would be completely not honest. So rest assured that I will defend you, and you have me on your side, and I will stand up for you to make sure that everything will be correct and that you are satisfied with the solution we provide. Okay. So let's start. Welcome, everybody. Good to have you again in our second partial already. Goes fast. However, the first partial was a bit short. This partial will be a bit longer, and then the final will also be a bit longer. And we have still a lot of interesting content to see. Today, as you can see on my background, it will be about the origins of life. I like this a lot because it's so interesting, and so many things are still unknown that it's very fascinating, I think. This normally was for the first partial, but I didn't want to rush over it and include it because our exam was a bit earlier than usually, and we moved this part to the second partial. It's better for you so we can see it quietly. So let's go over the content, guys. So I'll share Canvas with you, and let's dig in, okay? So this is the content, the origins of life. So we're going to talk about the origins of life, and as you will see, it will be a bit strange because we have a front page, we have an index, we have triggering questions, and then we have different kinds of theories. And why do you think we will see different kinds of theories, Leonela? Why will I not tell you just one theory, one thing? Why will we go over different kinds of explanations? What do you think the reason is for this?
Because they are not proven.
Yeah, some of them are proven, but it's true.
Because they are
Go ahead, Leonela. Go ahead, please. I want to hear you.
because there are multiple possibilities and like we don't really know which one is the correct one.
Yeah, it's correct. There is still so many uncertainties, and like Emilio says, not everything is proven yet. Certain things are proven that we don't want to close certain explanations because maybe things will change when new evidence comes up, and that's why it's important to see those different ones, to the different explanations. So yeah, you'll see here what we will see. We will have creationism, spontaneous generation, panspermia, biogenesis, and formation of Earth. There are a little bit more, but let's focus on the main ones, okay? We will also see a little video. I hope we can get to the little quiz as well. So this should be the thing that we do today in this index, okay? What we do know, or Ana Sofia, here it says, was life originated in the sea? Is this something that we know already or not?
No, because I think we've only discovered like super little parts of the ocean, so we don't have like a complete vision of what the ocean is or was like years ago. So I think we don't really know like the past of
Mr.
what we find.
Yes,
It
Emilio?
was
I
originated in the sea.
yeah, I think
Strange fact.
some bacteria or
Yeah, it's called
something.
Yes,
stromal.
and then the amphibians, and after that the reptiles, and then the mammifers.
Mister, it's like not a joke, but like the thing from Minions, like the movie that have you seen it?
Yes,
Like they start from the
bacteria.
water and then they started like millions of years, but there's there like the evolution of the like how they started like without they were like just bacteria and they had like fins and then those fins start like fins and legs so they can go to the land and then they start like the ones that stayed on the land they evolutionate so they don't have fins anymore and they could breathe like air without going into the water so
Mhm.
like this I do believe it's from the
Okay. Yeah, you're absolutely right, Isaac, and you're referring more to the evolution theory than the origin of life theories. But guys, we do know that life originated from the sea. That's with very little doubt. It's proven. We're sure. In fact, we're sure that life on Earth originated in the sea. To be more specific, it started with single cell organisms, and we still have those structures today of single cell organisms that are petrified. If you click on here, you will find some story about the stromatolites. Stromatolites, you can even find them in Cuatro Ciénegas. I don't know if you went to the Rio Mesquite. You have stromatolites in the Rio Mesquite. It's one of the earliest origin life forms we have, and we do know life originated from the sea. We have evidence of that. Also, if we look in space, for instance, Saturn has a moon, and the name of the moon is Titan. And this moon, it has liquid water like Europe. And they believe Europe, for instance, is other moon, and it's covered with ice, like ice sheet of several kilometers thick. And also, this Titan moon has atmosphere, and it's believed it has some water there. And it's the first places they will look for if there's maybe life in outer space. We also have evidence, it's not a theory, it's evidence that there was water on Mars. Okay, we know there is water on Mars because we found an ice cap, there is a north and a south pole on Mars, and there is frozen ice. And if you look at the structures of Mars, we know for sure that there was once liquid water on Mars because of the erosions. Check it. And so they even think that maybe we can find some life forms on Mars. But anyway, let's go over it. The first theory of life is creationism, and creationism is basically the most simple explanation that all cultures over all the world have different stories about, and basically it all comes to the same thing. There is one certain Almighty God, and that Almighty God, his name may be Jehovah, it may be Allah, it may be Buddha, it may be Shiva, goes by many names, and that that a certain God created it all. Okay, that's creationism, as simple as that. Many of you might believe this as well. It's part of many religions. It's something common. Even the Romans, like you see here, the Greek people, like Aristotle, they all had, because they couldn't give an explanation really, they really didn't know how life came into existence. So the most plausible and simple explanation is just saying that there is some kind of God that created it all. Okay, it's very romantic. There is many different stories about gods creating life on Earth. It's very cultural. If you look in India, there is different stories. The Chinese gods have different stories. What is really similar is between the Muslims and Jews and the Christians, because we have the same roots of religion, and basically it's all based on the creation of life by a divine power. Okay. um, You believe it or not, that's something personal, because we're touching religion here, and we respect that. But this is not something that is it's not something that is accepted in science. Okay, so we don't accept creationism in science, because if we use creationism, then there is no need to explain anymore, because then you have the answer already, and then yeah, it got made. So you stop with looking for answers, basically. So there is scientists that believe in creationism. It's okay, no problem with that. Uh, but we will not focus too much on this. Okay. Then the second theory we have is what we call the theory of spontaneous generation. I kindly remember you. Who remembers what we did? Emilio, you're really happy today. Maybe tell me, Emilio Marroquin, what is the spontaneous generation? Because we did already an activity about it.
They didn't know, so they couldn't trace how life was created, so they thought it appeared out of nowhere.
Okay, very good. It's also a very simplified um, explanation with very little justification, argumentation behind it. It's just that people believed that, okay, if it's not God who made it out of nothing, it came out of nothing. That poof, life all of a sudden was there. That's spontaneous generation. That life came out of nothing. It's that simple, you know. That life is meant to be. These are the persons that Descartes also. It's a very important French philosopher that also said that life it was meant to be, and it came out of nothing. Okay, that's basically we just have all the right ingredients for life to come out of nothing. And do we reject this spontaneous generation completely? Yes or no?
Yes, no.
No.
Because matter can't come out of nothing. There must be something.
Yes.
That's the. I believe that were the basic laws of matter.
Very good.
They didn't say it was out of nowhere. It's like a
Yeah, no, but Santiago is right. This is not a ridiculous idea, because if you have the right ingredients, if you have the right molecules in place, I mean, they're not talking about the chemical elements, not about molecules, but if you really simplify it, life came out of nothing. You know, it came out of nothing, the nothing that they didn't know what was the nothing. Now we know that the nothing is basically biomolecules, you know, and that life came out of those biomolecules. But it came just because, like Santiago says, and I agree with that, life is a consequence of the laws of nature. Okay, and that's why it's not completely something we reject, because it formed because the right ingredients were there. Okay, so you cannot say it originated out of itself or out of nothing. There was something, but those people, they didn't know what nothing or that some or itself was, or what that, where it exactly originated from. So it is a proper base for a theory. Yes, Emilio?
Are we talking about the theories about how life was formed, or in general, like the universe,
They go a little bit hand in hand.
or only living things?
We're really talking about life itself. Okay, think about the characteristics of life. We're talking about life. Where
Okay.
did that life exactly come from? Okay, we're not talking about the origin of the universe. That's another theory. There's other theories from it. Okay, the thing is that the most people assume that life originated on Earth. But as you can see in the next theory, the panspermia theory, it tells us a different story. The panspermia theory says that life not necessarily originated from the right combination of biomolecules from the sea. Maybe those first molecules, or the first microorganisms, they came with a kind of meteorite, or they came from Mars or from another planet, and by a rock or a meteorite, asteroid, whatever you want, it arrived to Earth. Okay, this is possible. This is something that we don't know for sure, and it's something we cannot reject. Of course, then you can ask yourself how did life originate on other planets? But it must have been in similar circumstances. But this theory basically comes out of the idea that certain planets might be older than planet Earth. Planet Earth is about 4 billion years old, and we believe that our planet Earth in some more billion years, it will look like Mars looks today. It will lose its atmosphere. It will become a desert. And it is believed that on Mars, many billion years ago, or not many, some billion years ago, the atmosphere was thicker and there was liquid water. So it's possible that the life we have on Earth is not originating on Earth itself, that it originated on the other planets, but that it evolved on Earth. Okay, we are not sure about this. There is no evidence. It's just a theory. Okay, so it's something we can also not reject. But these were theories that were very early postulated, and there's even certain religions like Scientology that put this into the extreme, that the aliens came to Earth and they planted humans on Earth and it's an experiment and I don't know what. So there's even a little bit extreme points about this. But panspermia theory says that, to say it in its most simple kind of spores or bacteria travel through space in debris from comets and meteorites, planting life on Earth, basically. Okay. I don't think this is the case, guys. I really think it's possible. I'm not rejecting this theory, but I do think that life originated on Earth because the conditions in space are so harsh that I find it quite hard to believe that life might travel on a meteorite through space. It is possible. I'm not saying it's not. Maybe in the core of a ice meteorite or something that life might have traveled. But I find it way more plausible that life originated in the seas, and we will see in a moment why.
Mr.
Yes.
Is
Mr.
it true that they find fossils on Mars, like the robot? They send it to
No,
Mars.
no, it's
Like
they
they
not call it fossils. What they found on Mars, I love a lot about space, so I do know about it. What they found on Mars is they looked into certain rocks and they saw some kind of characteristics of life in the rocks. What they saw were a high level of symmetry. They found certain formations that looked like fossils, and if you look at it, you could think, okay, this might be ancient life that is fossilized, but it's not absolutely sure because we also do know that certain minerals in the certain conditions with heat, temperatures, pressure, those kind of things, that certain minerals they make certain forms in stones. Think about certain sapphires, certain minerals, certain rock formations, they might have very symmetric and organized structure just because of the environmental conditions, temperature, humidity, pressure, that it creates like spectacular forms. I don't know if you ever heard about the wonder we have in Chihuahua. Have you heard about that?
no.
Well, in Chihuahua, maybe I show you guys because it's utterly beautiful. It's forbidden for the public because it's so delicate. Uh, let me search it. You should have heard of it, guys. You're Mexicans. It's unique. It's unique in the world. Um, show some. I'm gonna share you quickly.
Oh
So
yeah, I've heard of it.
they found in Chihuahua, they found no in Chihuahua, yeah, in Chihuahua, they found a cave, and inside this cave there is like not ice crystals. It's like special crystals, rock crystals, minerals, and they're huge, and they're found nowhere in the world, only there, and they still don't know how they were exactly formed. It's very special, this place. People, you cannot visit it because we breathe out carbon dioxide, and carbon dioxide is a little bit acid. And if you would let in tourists, then these crystals, they would get destroyed in very little time because the acid of the air we breathe out, I mean, it's not acid, but it has a higher acidity, would affect those Nika, they call it the Nika crystals, the world's most beautiful place, they call it. Um,
Teacher, there's a theory that says that there were minerals in water and that water filtered and then the minerals got like formed in crystals.
yeah, there is some theories about it, but
And
they
most
don't,
scientists think,
but look how big they are. But what is amazing that they are nowhere in the world as big as here. And if you would see this and you come from another planet, you might think as well that possibly this has to do with life, or that certain life has formed it because of the symmetry, the complexity, which are typical characteristics of life. And that's the same thing that happened on Mars. Okay, that's why I show it. So let's go to the next theory, and the next theory is called the psychochemical theory or the biogenic theory. Okay, um, this is in fact the one that is the most accepted one, and this is a theory that explains that the conditions on Earth in the primitive Earth were so special because of volcanic eruptions, electric storms, special rain, the atmosphere that has a special composition, and because of the lightning, the fire, the light of the sun, the radiation, the water that was already present, that you had this primitive atmosphere influence, and that these reactions because of the lightning, the fire, the sun rays, the radiation, that this formed basically the first biomolecules. And this is very interesting because we have proof of this. Okay, um, I come there in a moment.
Victor, can you
What
go back a bit?
we have, look, the Earth's formation, the Earth is about 4.6 billion years old, and we know that the Earth is formed in different steps. We know that because of the rock layers. We know that because we have gases that are captured in ice, in rocks, and we have a pretty good idea how the Earth was formed. Okay, I'm not going over step by step, but basically what happened is that we know that the Earth in its earliest stages was a big ball of lava, of magma. It was a fireball. Little by little, it cooled down. And basically what happens is, you know that the Earth has like iron core. And why is the core iron? Because iron is one of the most heavy elements of the periodic table. So it's typical that gravity, that's why the Earth is round, because gravity causes the Earth to be round and to attract all molecules at the same way. That's why everything in space is basically round, more or less round. And what happens is that the most heavy elements, they sink to the core because they are more subject to gravity. And that's why we have a molten iron core, because it's the most heavy element that is abundant on Earth. And that's why we have a magnetic field. And thanks to the magnetic field, we have an atmosphere. And then the lighter elements, they're more on the surface. So you have a iron core, then you have rocks, then you get sand, then you get other elements, gases and whatever, that still possibly stay captured in the core. But what you see is the lighter elements, they're on the surface. So you have the water, 70% of the Earth is water. This is on the surface. And then the even more lighter elements like oxygen, nitrogen, is 80% of our atmosphere, and it's one of the lightest elements. This is all atmosphere. It's on the outer layers. So don't think this is a coincidence, okay? It's because of the gravity and because of the weight, the mass of the elements. That's why the atmosphere is on top. Then you have water and land, and then below that you have rocks. And the deeper you go, the heavier the elements are. Okay.
Mister, can you go back for like 10 seconds to take a photo?
Can I go back where?
Like in the chemical theory, the biogenic theory, please.
Yeah, but there we go still. So basically the biogenic theory, is the one that says that life formed out of the fire that was on the earth, the electric storms, the condition of the atmosphere, the radiation and the sunlight. If you take all this together, it was like a big fire show with lightnings that were in fact the energy to form the biomolecules. Okay, and this is one of the theories that is the most accepted because we know how the earth was formed, and that's what I just explained to you. You know that our earth was a big ball of lava, of fire, and then little by little it cooled down. The heavy elements went to the center, the lighter elements they stayed on the surface. Okay, and in those lighter elements, especially water, we know that life was formed. Okay, the first organic molecules were formed there. And this, we have proof of that. And that's what you have to know here in 1950, Stanley Miller and Harold Urey, it's called the Miller-Urey experiment. They did something very interesting. What they did is they brought the primitive sea to the laboratory. So they took an Elnemeyer or a beaker and they made ancient seawater, and then they would put electricity on the seawater, and they would put gases on in the flask, and they would do an experiment just by adding electricity, light, and just having the cocktail there. What they would notice is that in the flask, in the experiment, they would see that if you just put the atoms in there that were there, which were there on the primitive earth, that all of a sudden they would see the formation of biomolecules. So they would see that certain amino acids were formed. They would see that certain mini carbohydrates would form just out of nothing, basically, just because you have a cocktail of this, of the necessary atoms, and thanks to the electricity and the lightning and the heat, the formation of these molecules occurred. Okay, so we have proof of that. We formed basically the building blocks of life in the laboratory. We can do that. We can take just the atoms, we put them in the right conditions, add lightning, temperature, a bit of heat, whatever you want, and they saw that life, not life, they saw that the building blocks of life would form in these conditions. And imagine this on a really, really big scale, then this was basically what happened on the primitive Earth. And don't forget, primitive Earth had billions of years to do this. You know, it was a lot of lightning happening. So bacteria, they had plenty of time to form themselves. Okay. And later we come how complex life was formed, because simple life is formed thanks to small biomolecules. But then they think that two bacteria, they work really well together, and they form the symbiosis, and that's called the endosymbiotic theory, that out of simple cells, complex cells were formed. But we will see that later. Okay. Any questions so far? So here it says we had the
So this is the most likely theory.
Yeah, this is basically the most accepted theory indeed, because the conditions on the primitive Earth, we had hydrogen, sulfur, carbon dioxide, carbon monoxide, nitrogen, and water, which is basically, we know this was there in the primitive atmosphere, and we know these are the elements, the atoms, that we need to form life. So this has been proven by an experiment, because those two scientists, they brought those elements in the laboratory, they faked a little light storm in the laboratory, and they would see that indeed big organic molecules would form from those conditions, and they would be in agreement with the characteristics of life. So this is really a proof that life can form in the right conditions. And that's what I also accept as a scientist, that I believe that life was formed in the ancient earth, in the oceans. Okay, it's not a belief, it's the best evidence we have. Of course, a scientist never closes uh, other options, so that's why we see a lot of theories. Maybe this from outer space might be true. We don't have evidence of it. The evidence we have is the Miller-Urey experiment, which is a very good experiment that we could even do that in the lab, you know. So let's watch a little video about this. I had planned to see this. All right, 1 second to share the audio with you correctly. go.
Hello, I'm Julia Child. I'm in my own kitchen today and I'm boiling up some primordial soup. And there is a primordial soup machine. We're doing a recipe for the chemical building blocks of life. Today,
Hey guys, Joe here. Some people would argue the most important year in the history of soup was 1962, when Andy Warhol released his super soupy pop art. But I think soup's best year came a decade earlier in 1952, when a scientist named Stanley Miller first cooked up primordial soup. Miller's experiment took some simple chemicals like those found on early Earth, bubbled them up through a tube, zapped them with electricity, and after a few days floating in this soup, he found amino acids, the building blocks of proteins and one of the essential ingredients for life. This idea that life's origins could be found in a puddle of chemicals is an old one. In the 1920s, two different scientists theorized about life coming from what they called a prebiotic soup. And this soupy speculation even goes back, unsurprisingly, to Charles Darwin, who in 1871 wondered if life may have formed from chemicals in some warm little pond. What made Miller's experiment so special was it gave us proof regular non-life stuff could become cool life stuff super easily. But every living thing we see today, even the most basic bacteria, is so complex, built of such intricate machinery, it's impossible to imagine they just popped into existence out of some soup. That's because they didn't. We're gonna go on a journey in search of the origin of life, and along the way there will be a few forks in the road, maybe a couple speed bumps, and we're gonna need help from a couple friends. We'll come to see that Miller's primordial soup isn't exactly how this story began. But the first question we should ask isn't how life started, it's when.
Life on Earth couldn't exist before Earth existed, and it formed around 4.5 billion years ago at the dawn of the Hadean Eon. Soon after that, another planet collided with the young Earth, melted the entire crust, and created the moon in the process. After the crust cooled, there was even some liquid water, at least for a little while. Because for the next couple 100 million years, Earth was showered with hundreds of massive space rocks. The oceans boiled away, the crust melted again, and Earth was basically no place for life until things settled down about 4 billion years ago at the dawn of the Archean Eon.
This is the earliest possible time that life could have started on Earth, the beginning of what we call the habitability boundary. And fossil and chemical evidence tell us that early microbes existed by 3.7 billion years ago, what's known as the biosignature boundary. At some moment in here, non-life became life. We call this abiogenesis. I don't have a time machine. As far as I know, no one does. Therefore, we can't go back and find that exact moment. But if we could, what would we look for? This brings us to the next big question on this journey. What is life? You'd think biology would have a good definition for life, the thing it studies. But as a biologist, I can tell you this is much harder than it sounds. In one chapter of biologist J.B.S. Haldane's 1949 book, What is Life?, he literally writes, I am not going to answer this question. Life is a board game, a delicious breakfast cereal, and a highway? According to the dictionary, it's the time between birth and death. But none of these definitions really help us. I think we might be asking the wrong question, because life isn't a thing that things have. Life is what living things do. In school, many people learn a checklist for the characteristics a thing must have in order to be alive. Mrs. Gren. But this list came from looking at life as we know it today. Life at the very beginning was probably much simpler. A cat-loving physicist, Erwin Schrödinger, looked at all these things that life does and saw something only a physicist would see.
According to the second law of thermodynamics, the universe works to maximize entropy. In other words, energy and matter are slowly inching towards perfect equilibrium everywhere. But inside living cells, there's a huge amount of order and complexity. In 1944, Schrödinger defined life as a struggle against entropy, the persistent resistance of decay, the preservation of disequilibrium. Since then, we've learned a lot more about entropy, and it may be that the rise of complexity is as inevitable as its decay.
That sounds pretty good. Life creates these little closed systems where it works to keep things nice and ordered. But this definition still leaves out one important thing: living things evolve. Inside the very first living things must have been molecules, chains of atoms that carried information, instructions for building things or codes for doing stuff. These molecules must have copied and made more of themselves, some a little different than the others. And a few of those codes and instructions must have been better at doing whatever they did, so they made even more of themselves. What we're describing is evolution by natural selection, Darwin's famous idea. And for life to move forward, it must have been there from the beginning. Life is a product of evolution. With all this in mind, maybe we're finally able to come up with a better definition. Life began the moment that molecules of information started to reproduce and evolve by natural selection. And now that we have a definition, and it's a mouthful, we can make some rules for what something has to do to be alive. Here they are. A living thing must work to avoid decay and disorder. To do that, a living thing has to create a closed system or be made of cells. They have some molecule that can carry information about how to build cell machinery. And this information must evolve by natural selection. Sounds pretty good, but rules are one thing. The ultimate question is, how would this actually happen? Let's take these rules one by one. What would it require for these things to arise? And most importantly, how likely are each of these steps based on what we know from good old, real, actual hard science? Today, no matter where we look in the tree of life, most cell machinery is made of protein, chains of folded amino acids. When modern cells make proteins, they copy genes from DNA into RNA and then use that RNA as a blueprint for making the proteins. We call this universal pathway the central dogma of biology because it sounds really cool and because it's something that all life shares. But there's a paradox hidden in there, a puzzle. It's a chicken and egg problem. DNA needs proteins to make more of itself, and cells need DNA and the instructions it holds to make proteins. So which came first? We can solve this paradox in a pretty simple way. Just get rid of DNA and protein in the earliest days of life and let RNA do everything. RNA is the molecular cousin of DNA. It contains the same 4-letter alphabet code as DNA, only T is replaced by a similar molecule, U. And instead of 2 strings in a helix, RNA is usually found in just 1 string. RNA is special because in addition to carrying information in that 4-letter code, it can fold up into interesting shapes and actually do stuff. The same way that protein enzymes can do all kinds of chemical reactions, RNA enzymes, called ribozymes, can work life's machinery too. It's now thought that life began in an RNA world. Before DNA became a more permanent form of storage, different RNA chains could have carried information and been the machines for all of life's important chemistry. Unfortunately, the RNA-only world went extinct more than 3 billion years ago. But we can make these RNA enzymes today. Scientists have constructed ribozymes that can copy themselves, just like DNA gets copied. And these copies occasionally have errors or changes, so RNA can evolve too. If you need more proof, you can find it right inside your cells. The ribosome, the massive structure that stitches amino acids into protein, is mostly RNA. We also find nucleotides, the single molecular units of RNA, inside a bunch of other molecules our cells need for metabolism. This all makes sense only if the earliest days of living chemistry were dominated by RNA. And it solves our chicken and egg problem. The RNA world takes care of 2 of our 4 rules: a molecule that can carry information and that can evolve. To find answers for the other 2, we need to ask one more question. Where did life begin? There's been a lot of theories about where life came from, but they boil down to these. Either life arose on Earth or life arose somewhere else and was brought here. It's well known that space is full of the chemical building blocks of life, from amino acids to DNA and RNA letters, buried inside meteorites like this one that fell on Australia in 1969. It shows the chemistry that makes biological molecules can happen pretty much anywhere. But the idea that life was delivered to Earth on space rocks, which goes by the awesome name panspermia, there's just no proof it ever happened. And it doesn't really explain the origin of life anyway. It just moves it somewhere else. Life probably started here. No, zoom out a little. Okay. We know early Earth had plenty of chemical ingredients, but the problem with that old idea of primordial soup is that soup can't do anything on its own. Those chemicals can't react without outside energy. We get a hint of where this primordial energy came from by looking, again, at our own cells. Instead of lightning or heat energy, our cells pile up a bunch of hydrogen ions, protons, on one side of a wall, let them flow downhill, and use this like a water wheel to push on cellular machinery and make things like ATP in the mitochondria.
The powerhouse of the cell!
We burn food to keep our hydrogen pump going. But the first life forms wouldn't have been able to do this because tacos hadn't been invented yet. Instead, they would have needed some natural source, and they could have found it at the bottom of the ocean. Deep sea hydrothermal vents are covered in microscopic little pockets, which could have served as molds for the first cells. Molecules with one oily water-hating end and one water-loving end have this neat habit of forming bubbles and sheets all on their own. And there were plenty of these in the chemical soup near deep sea vents, ready to give rise to the first cell membranes. These vents also create natural streams of hydrogen ions near those little pockets in the rock.
Imagine an early life form sitting there wrapped in this little membrane bubble, with a free source of energy flowing by, powering all the work it takes to create ordered life and resist entropy. But this would have been the absolute simplest form that life could take. For this life form to become life that looks like what we know today, a lot more stuff had to happen. It had to switch from storing its genetic information in RNA and start using DNA. Instead of using RNA and ribozymes to run all of its cellular machinery, it had to start stitching amino acids into proteins. This opened up new possibilities for making and storing energy that let early life become free-living and more complex. One of these complex life forms is the ancestor of everything alive today, the last universal common ancestor, or LUCA.
This is the end of our journey, searching for the origin of life on Earth. And a lot has happened since. This story is based on things we've actually seen, not just on what's possible. We've figured out when life could have started. We've come up with rules for what life is. We found clues inside our own cells that explain how the first life satisfied these rules and where that life might have started. The only question we haven't answered is why, but that's not really a question for science, is it? There's still quite a few gaps to fill in this story, and if you're looking for a nice, neat answer of how life started, you're probably not gonna find it. Life is just a thing that happens. It's still happening today, and it will evolve and continue as long as there's a place it can happen, on Earth or elsewhere. Darwin didn't know it when he wondered about that warm little pond full of chemicals giving rise to life, but his theory of how things change and adapt turned out to be so powerful it encompasses life not just in its endless forms, but also in its first ones. Stay curious. Wow, that was a lot. This is probably the deepest story I've ever done on this channel, and it's one that involves some of the science I actually used to do, so this was a lot of fun for me, and I hope you enjoyed it too. But this is only part of the story of how life began. What happened before to make Earth a place where life could happen? And what happened after chemistry became biology? What life form lives at the bottom of our tree of life? For those answers, go check out these videos from our friends at PBS Spacetime and Eon.
Okay, guys, I think that's really an excellent video because it summarizes it all. Please review it. You can do a little quiz here, a Pac-Man quiz. We don't have time anymore to do it. I would recommend you to do it on your own. And there is also a little activity that you can do in groups. We will do that tomorrow about the origin of life. You just have to summarize the origins of life that we saw today. And that's basically it for today. Anybody has questions about this before we finish? No, perfect. Then we see each other tomorrow. And yeah, have a nice day, guys.
Bye, Mr.
Thank
Bye,
you,
Mr.
Mr.
Thank you.
Bye, teacher.
Bye, Mr.
Bye.